Okay, on my screen right now, you are looking at Form A of yesterday's quiz. So I'm going to go through this, but if you don't have Form A, you're going to be skipping around looking for the specific questions that we are talking about. Number 1 on Form A, you guys did pretty good on it. 80% of you got this question right. But I will say that is lower than the average that the campus had overall. So we struggled with it a little bit more than everybody else, but some of them we did better on too. But it says, a runner is standing, stretching against a wall. If he pushes horizontally with 5 newtons against the wall, what can you assume about the motion of the runner? So if you look at these options here, the first one says the runner is in equilibrium. Equilibrium is going to apply to a situation where everything is balanced. So it could say balanced forces or something, and that would be similar. But equilibrium means that you have equal and opposite forces and everything's in balance. And that is true. If you're standing, stretching against a wall, your forces would be balanced. You'd push against the wall with 5 newtons, but you'd also have that support force from the wall pushing on you. And so if you were drawing a free body diagram, you'd have those equal and opposite forces. So A is true. The runner is still. That would also be true. You would be stationary if you're just standing, leaning against a wall and at equilibrium. C says the runner experiences a net force of 0 newtons. That is also true. Again, because he's just standing there stretching against the wall. So the answer to number 1 should be D. All statements are true. And again, a couple of you guys missed that one. You picked one of the other letters, but all of those statements are saying the same thing. And so they all have to be true. If one of them's true, they're all true anyway. So number 1 should be D. Does anybody have a question about number 1? Again, whatever you need to write down on your paper, if you're taking notes to help you remember any of this so that you don't miss it tomorrow, that'd be a good idea. Number 2 on Form A has this graph. So again, if you don't have Form A, you need to look for this graph on your paper, and it says examine the velocity versus time graph below. During which time interval would the forces acting on this object be balanced? You guys did really good on this one. Only 2 people missed it. So we're at 91%, which is higher than the campus of 85. So good job. All right. So it says the options are from 8 to 10, from 0 to 3, from 6 to 8, or just at t equals 0 and t equals 10 seconds. So first things first, pay attention to what type of graph this is. This is a velocity time graph. And if we're looking for balanced forces, you also need to think about what does that mean about the object's velocity. Balanced forces, or a net force of 0, means that you have 0 acceleration. Again, 0 acceleration on a velocity time graph, that means you want a slope of 0 because the slope of your velocity time graph is your acceleration. The only points where we have a slope of 0 is right here and right here. Only one of those is a choice in the options below. If they were both there, you'd have to pick them both, but they're not. And so the only one that is here is answer choice C, from t equals 6 seconds to t equals 8 seconds. At that point, you have constant velocity, and if you have balanced forces, that's what you would expect to have, is constant velocity or being at rest, but no acceleration. Okay. Anybody have a question about number 2? Again, if you see something like this tomorrow, don't miss it again. Jot down whatever you need to. You can even draw what it would look like on an XT graph, just for practice if you want. All right, number 3 on Form A is this question right here. It says a 25 kilogram object experiences a 300 Newton net force. The magnitude of acceleration that the object experiences will be. Every single one of you got this question right, which the campus overall was 95%. We're at 100. Good job. This is a really straightforward calculation. Okay, it is simply F net equals MA, and you have in the question your net force is right there, and you have your mass right there. And so if you are substituting this in to F net equals MA, it becomes 300 equals 25 times A. And if you want to solve for A, you're going to have to divide both sides by 25. 300 divided by 25 gives you your answer, which is 12 meters per second squared. A is the answer to number 3. Questions about this one? All right. I didn't figure since nobody missed it, but you guys did miss this one. And when I went over it in class, I told you guys, this is a common misconception. If anytime I say that, you know it's going to be something that shows up on your quiz or your test. And it's something you should definitely take mental note of, but also write down on paper. And some of you did not do that, or at least forgot about it between now and then. This question, 55% of you got it right, but of course that does mean that 45% of you got it wrong. If it makes you feel any better, the campus average was a 41. So again, I don't know if 55 is anything to brag about, but we were doing a little bit better than the average. The question says, which force diagram could depict an object moving to the left with a constant speed? Again, there are 2 parts to this that I need to think about. I need to think about moving to the left, and I need to think about constant speed. So let's talk about moving to the left first. When you look at a free body diagram, you cannot tell which way these objects are moving. That part of the information is not helpful to me at all, because based on this alone, it could be any of them. Okay, so again, moving to the left is not the same thing as accelerating to the left. I can tell that. When I look at these, I can see which one or which ones would accelerate left. That doesn't mean moving left. Okay, please do not confuse the two. So this is not helpful. However, this is. Constant speed means, and we've seen it a couple times already, constant speed means I have to have balanced forces, and that is something I can look for. If I look at these options, the only one that has balanced forces is this one. Okay, the rest of these have a net force. And so this would accelerate. This has a net force of 5 newtons to the left. It would accelerate to the left. This one has a net force of 5 newtons to the right. It would accelerate to the right. This one is obviously 20 newtons to the right. Okay, all of these would accelerate. The only one that could have constant speed is the one that has balanced forces. Could it be moving left? Sure. It could also be moving up or down or right. We don't know, but it just says could. Okay, and so this is your answer. It's the only answer you can choose is answer choice D. Okay, by the way, again, I mentioned this already. This is probably the one y'all picked. Yes, it is. If you got it wrong, you picked A, which means you were looking at moving to the left and you confused it with accelerating to the left. Okay, this object could be moving to the left. If it is, it's speeding up. It could also be moving to the right. If this object were moving to the right and these forces acted on it, it would be slowing down. Again, we don't know which one is happening. So make whatever note you need to, but you cannot tell which way an object is moving by looking at a free body diagram. You can only tell the direction of its acceleration, and that is not the same thing as its velocity. That can help you figure out if it speeds up or slows down, though. Okay, any questions about number 4? All right, don't miss it tomorrow because you'll see something similar. Number 5 on Form A. This was also one that everybody struggled with, just campus-wide. It's the same percentage actually as the last one. 55% of you got it right for number 5, and the campus average was 36, so better than that. But let's go ahead and take a look at it. Because obviously this was a common misconception that people had, or they misread something. It says an object is moving with constant non-zero velocity. Which of the following statements about it must be true? And it's even italicized, so you know it means it's important. Which ones have to be true? So basically, if an object has constant non-zero velocity, that is a wordy way of saying, hey, it's moving at a constant rate. Okay? It's saying it's constant but not zero. So it's moving. Zero would be stationary. So it's moving at a constant speed or constant velocity. So what has to be true? There are a lot of things that could be true about things moving at a constant velocity, but what has to be true? If we read the first option, it says the net force on the object is 0. That has to be true. That is actually the answer to this question, is answer choice A. If you have an object moving at a constant speed, that has to be true. Okay, if we read the next one, it says a constant force, I'm going to go ahead and circle A real quick. A constant force is being applied to it in the direction opposite of the motion. Could that be true? Yes. Does it have to be true? No. Okay, that does not have to be a true statement. Okay, it could be true if you had something that you were pushing along a surface with friction. Then sure, there'd be an opposite force, opposite the motion of the object, and you'd have to maintain your force to equal that. Yeah, that could be true, but it doesn't have to be true. If you're in a frictionless surface, again, B would not be true. C, a constant force is being applied to it perpendicular to the direction of motion. We've had, on all of our examples thus far, we've had a normal force from the surface. We've had things like that where it's moving along the ground, but does that have to be true? No. Okay, if you have again, an object just moving at constant velocity in space, there's not a normal force acting on it. All right, the next one says a constant force is being applied to it in the direction of motion. Again, that does not have to be true. If you were pushing something on a friction surface with friction, then yes, both B and D would both be true. Okay, but they don't have to be. So the only thing that has to be true is that the net force has to be 0. Otherwise, it's not at a constant velocity. So the answer to number 5 should be A. Does anybody have any questions, clarification needed for that one? Okay. Number 6. Number 6 was your second most missed question. So if you missed something in this class period anyway, chances are it was number 6. Y'all got about the same as the campus average, but that's like 42%. So let's take a look at number 6. It's this diagram here that you're looking for, and it says, 2 students push against each other on a 25 kilogram box. The box accelerates to the left at 5 meters per second squared. What is the magnitude of the force applied by student B? Note the image is not drawn to scale. So if you look at this, first things first, before you do any math, let's think about what this means up here. If this box accelerates to the left, that means my net force has to be to the left. Okay, again, your net force is in the same direction as your acceleration. So my net force has to be to the left because it says it's accelerating left. And as soon as I see that my net force has to be to the left, that means that this has to be bigger than this. Okay, because that's what gives you a net force to the left, is if this force is larger than that one. So before I do any math, I can eliminate 2 of my answers. Because this, and I know this is small, this says 100 newtons, okay, over here. And this has to be bigger than 100 newtons. That's the only way I get a net force to the left. Well, that means it can't be 20 and it can't be 100. So right off the bat, you have a 50-50 shot if you just read it and think about what it's saying without even trying to do the math. Okay, and you can do that a lot of times. You can start eliminating some things. So it's either 125 or 225. So let's see which one it is. Now we have to do some math. So if I want to solve for the force of student B, you'll notice on my board, there is not an equation for force of student B. Okay, just like there's not an equation for applied force or tension force or a lot of those other forces. Okay, and so what you need to do if you're trying to solve for a force where you don't have a formula for it, you have to use that net force is the sum of the forces acting in that direction. So in this case, it's all in the x direction. So I'm going to have to use that F net x is equal to the sum of my forces in the x direction. Oops, I'm off the screen. Okay, and so that means if I can get my net force, then I can set it equal to this plus this. And I have another equation for net force, and I can use that to figure out what the net force in this scenario is. F net equals m times a. Well, they gave me a mass, and they gave me an acceleration. So I can figure out the net force on this scenario, and I already know student A's force, so I can find student B's force. Okay, so again, F net equals, my mass here is 25. My acceleration is 5 meters per second squared to the left. So I'm going to put a negative in front of it to make sure I remember it's to the left, which means that my net force is negative 125 newtons. Okay, or 125 newtons to the left. That is not the answer to the question. We're not done yet. Okay, so you'll notice that is a choice down here. Okay, but that doesn't mean it's the answer. We need to see if it's the answer or if it's something else, because it could end up being the same number. So we need to check it. So again, that's my net force. So now we're going to plug it in up here into this equation. The net force is equal to the sum of my forces. Negative 125 is equal to student B's force plus student A's force. Student A's force is given to me as 100. Student A's force is to the right, so it's positive 100. The net force was to the left, so it's negative 125. Do make sure you use the right signs, otherwise it will throw you off your answer. So if I want to solve for student B's force, I just need to isolate this. I'm going to subtract 100 from both sides. Okay, and that means that student B's force is negative 225 newtons. Okay, but if I look at my choices, none of them are negative, and that's because it says what is the magnitude of the force applied by student B. It is to the left, that's where the negative's coming from, but the magnitude is 225 newtons, and so the answer is answer choice D. Does anybody have a question about number 6? No? Again, it's a couple of different processes that you have to go through in your mind to solve this, and you will have questions like this, and you had questions like it on your problem set and your unit summary as well. So if you need to look back at some of those, please do that. Or if you haven't done the unit summary, please do that. All right, number 7. Again, if you do not have Form A, you are looking for this picture and this question, and it says, an ice skater on a frozen lake pulls a toboggan across the surface of the ice as shown. Friction is present. The skater exerts a constant rightward 600 Newton force for 6.2 seconds to accelerate the 250 kilogram sled from rest. The coefficient of friction between the ice and the toboggan is 0.071, which free body diagram correctly shows the forces described in the scenario above. There's a lot of information in that scenario, but here's the thing. If we're trying to match one of these free body diagrams, well, I can't eliminate any based on the arrows alone because they all have 4 vectors, which is perfect. That's what they should have. Okay, they all also show the same rightward 600 Newton force, so can't eliminate anything there. So what I would recommend that you do is start with the force that I tell you to start with when we draw these, FG. Start there. And the reason I say that is because these have different numbers. At least there's 2 different numbers down there. So let's figure out what's supposed to be down there. FG is M times G. If I read the question, the mass of the sled is 250 kilograms, and I know that's a mass because kilograms is a mass unit. So the weight should be 250 times that 9.8. Okay, technically negative 9.8, that's why the arrow's down. But I'm going to get the magnitude. 250 times 9.8 gives me 2,450. That's the weight. And guess what? These 2 put masses down there. That doesn't go on your free body diagram. They labeled it as a weight, but it's not. Okay, the weight should be this value here, 2,450. So it's either C or D. The other next thing you can check is Fn. Again, my sled is not accelerating vertically, so Fn should be equal to Fg. It should also be 2,450, and these both have that. So we're good there, which means the only thing left to check is friction. Okay, my equation for force of friction is mu times Fn. In this equation, guys, this is normal force. This is not net force. I had some people asking about that before. This equation, this is normal force. My mu value is 0.071. Fn is 2,450. Again, it's equal to that. You can see it in the diagram. So if I multiply 2,450 times 0.071, then I get a force of friction of 173.95. Again, it's to the left, so technically it's negative, but you don't see that on the diagram, and that rounds to 174. So the answer to this should be C. And really it was the friction and the gravity that gave it away. This one, by the way, you'll notice they did label the coefficient of friction on their diagram. That is not a force. It does not go on your diagram. You use it to find the force. But this is the force. Are there any questions about number 7? All right. Let's take a look at number 8. Number 8 says, Tom pushes a box with a force of 25 newtons to accelerate it across a room. If Brian pushes an identical box with twice the force, then Brian's box will have how much the acceleration, whatever. You're trying to fill that in that blank. We talked about the relationship between force and acceleration. And you can see with this equation, you can see that relationship. Or if you're trying to look at the effect on acceleration, it is actually a little bit easier to rearrange the equation. So it's set equal to A by dividing both sides by M. And so A equals F divided by M. But you can answer it either way. If you want to use the equation to help you see the relationship, you can. You can also memorize the relationships or use a little bit of common sense in this case. Okay, I'll talk about the common sense part in a second. But if you were to look at using twice the force, okay, and you can plug in fake numbers here if you want, okay, and just see what happens. But if you were to double this and this stays the same, then mathematically speaking, doubling this will double this. That is your answer. You will get 2 times the acceleration because force and acceleration are directly proportional to each other. So back to the common sense part. If I push something harder, is it move more or less? More. Again, that's the part I'm talking about. So sometimes it sounds way more difficult than it is, but you can use that because you already know. You hopefully already know if I push something harder, it's going to accelerate more. Just like you already know if I push something that's heavier, that has more mass, it's going to accelerate less. Okay, if I use the same force. So you already understand these relationships just from daily life, but if you want to look at it in terms of the math, use the equation. You can plug in fake numbers if you want, okay, and you do whatever you need to. But you can say like 1 equals 2 over 2. Cool, double it. Now this becomes 4 over 2. So guess what? That went from 1 to 2. You can do that, okay, and it doubles. All right, so questions about number 8? Only 2 people missed it, so you guys did good on it. Number 9. Number 9 says, my veterinarian found my cat Ruby's weight to be 39.2 newtons at her last checkup. What is Ruby's mass? The equation that we use that allows us to solve for weight or mass from one from the other is this one. Fg is weight. It is equal to mass times gravitational field strength or gravitational acceleration on Earth. That is 9.8, or more specifically, negative 9.8. Okay, so if I wanted to find Ruby's mass, then I know her weight is 39.2. Technically, it's negative 39.2 equals her mass times negative 9.8. And if I want to solve for this, I'm just going to divide 39.2 by 9.8. And when I do, I'm going to get 4. So Ruby's mass would be 4 kilograms. And again, that was just a pretty straightforward calculation to get that. Questions about number 9? A couple people missed it. Okay, I think those of you that missed it put this because you like multiplied by 9.8 instead. Make sure you go back to the equation. Number 10 also has to do with Ruby, and it says if Ruby takes a trip to Mars to form a Martian cat colony, which correctly describes her weight and mass on Mars. Note, Mars has about 2/5 the gravity of Earth. And this goes back to our notes. When you talk about weight and mass in space or on a different planet or on the moon, your mass never changes. Okay, the mass doesn't change. So please don't tell me that her mass is 2/5 as much, because it doesn't change, which means it also couldn't be that. Okay, your weight is what changes. When the gravitational field strength changes, you weigh more or you weigh less. But the amount of matter that makes up you does not change. Okay, but her weight would be 2/5 as much. That's just something you need to memorize. You can kind of see it in the equation as well, but I would definitely memorize that. Questions about number 10? All right, number 11. Number 11, let's see, how'd you guys do on number 11? 73% of you got number 11 right. You actually did pretty good. I imagine that's better than the campus. It's about the same. All right, so we will work through number 11, but I'm going to work through it after lunch because I won't have enough time to finish it right now. So we're going to stop right here, and we'll come back to number 11 after you guys get back from lunch. 15 equals m times 1.5. And of course, if you then were to solve for mass, I'm sure you can tell just by looking, that's going to be 10. Okay, and so the mass of this desk is 10 kilograms. And I wouldn't know that if it weren't for the first part of the question. Okay, so we had to use that to get the mass. And now we can use this mass for this identical desk down here to solve this second part of the problem. So the second part of the problem, there's more than one force. And so whenever I have more than one force, I do want to recommend that you draw a free body diagram. So I'm going to draw a diagram showing my same 15 newtons, but also my friction, because it says that there are 8.3 newtons of frictional force. Okay, and I am going to draw my friction so that it is in the opposite direction as the force I am applying to cause it to accelerate. And so my friction's always opposite the direction of my motion. So using this, okay, I can figure out my net force, which I need because if I want to find acceleration, I'm going to need net force and mass, and the same equation that I used a minute ago, I'm going to use again, F net equals ma, but this time I have a different net force. And so I need to look at the diagram that I drew to figure out what that is. Again, the net force is equal to mass times acceleration, but I don't know the acceleration. However, net force is also equal to the sum of my forces, and I do have those. And so my F net here is going to be equal to 15, and that's going to be positive 15 because it's to the right, plus negative 8.3, which really means it's 15 minus 8.3, and 15 minus 8.3 is going to give me a net force of 6.7 newtons, and it's going to be a positive, or to the right. Okay, but that's my net force. That's not the answer to my question. Okay, we're not done yet because the question wants the acceleration. And so now that we have a net force and we have a mass, we can find the acceleration. Going back to F equals ma, 6.7 equals, my mass was 10 times my acceleration. And so if I want to solve for A, I'm really dividing 6.7 by 10, which is going to give me answer choice A, 0.67 meters per second. And again, you can check your sign as well because it should accelerate in the same direction as the net force. The net force was positive, and so is my acceleration in number 11. All right, any questions about number 11? Okay, let's see. Number 12. Number 12 looks like y'all did pretty good on it. 83% of people got it right. So let's take a look because most of y'all got this. It's about Martha sitting on a swing. And it says, in the picture below, Martha is sitting motionless on a swing. What is the net force on Martha? And yes, if you zoom in, or if I zoom in, or if you look really close at your paper, you can see what that net force says, but you don't even need to be able to read the diagram because it says she is sitting motionless. And so right off the bat, if I see that, if I see somebody's at rest, my net force is 0. Okay, and so that's the answer you're going to select here is 0 newtons. However, if you were to, let me see if I can zoom in, if it'll focus. This is 245, 245. Add those together, you get 490 newtons up, and that's 490 newtons down. Again, if you do have two forces that are both in the same direction, you add them together. Okay, so that's 490 up and 490 down, which is still 0 newtons. Let me zoom back out. All right. Questions about number 12? All right, number 13. Some of you did have problems with number 13. The average on number 13 was a 57, but the campus was a 49. So again, we're doing a little better than that average, but nothing to brag about whenever we're down there. So definitely want to listen to this one. You're going to see a question kind of similar in terms of the things it's going to ask tomorrow. It says, a skydiver's falling motion prior to pulling his parachute is shown in the position time graph below. Air resistance is present. The skydiver reaches terminal velocity from a time of 65 seconds, which is like right in here, okay, somewhere in there. where did it go? So until the end of the graph where he reaches a constant velocity. So you see here, this part of the graph that's a different color. It's a different color because it's a straight line. And so you have this acceleration occurring here, and here the acceleration stops and you have constant velocity, and we said that that was called terminal velocity in our notes the other day. Okay, that's all this, it's just basically describing what's in the graph. What must be true regarding the forces acting on him during this time? And so it wants to know what has to be true about the forces on him right here. And we know that there's really only two forces acting on him as he is skydiving. Of course, he's falling due to that force of gravity pulling him down. And then we also have an upward force of air resistance, which I'm not going to finish drawing it yet. But your air resistance is upward. And whenever you jump out of a plane to skydive, or if you drop a ball, okay, that initially you have very little air resistance, and it grows and grows and eventually becomes equal and opposite to the force of gravity. That's what terminal velocity is the point at which that happens. Okay, and so when that happens, now you have balanced forces, and that's what gives you your constant velocity, is the fact that you have balanced forces due to the fact that the force of gravity is equal to the force of air resistance. And that's what answer choice B says. Now, I asked you guys about this in the notes the other day, and I said, what's going to happen when these forces are equal? And I don't know if it was this period or a different one, but I guarantee you at least one person said it out loud, but probably more than one person thought it. Okay, and somebody told me that you would stop. No. Okay, if you are falling and this happens as you're falling, you're not going to stop moving. It's not like a Roadrunner cartoon where Wile E. Coyote just stops midair. Okay, you still fall. You just start falling at constant velocity. The acceleration becomes zero. It doesn't mean you're not moving. Again, acceleration of zero, constant velocity, net force of zero, whatever you want to think about whenever you think about this, just means you're not accelerating. It could mean you're at rest. In this case, it doesn't. Okay, or it could mean that you're falling at a constant rate, and that's what's happening here. They were already moving, so they stop accelerating and they fall at whatever that fastest speed that they reached was. That's what terminal velocity is. Okay, so don't tell me that they stop, please, on your test tomorrow. Does anybody have a question about number 13? Yes. Anybody else? Okay. Number 14, we are almost done. And number 14 was the most missed question in I think all classes. So listen up. Actually, yep, barely more than number 5 was. Let's see how you guys do on it. A little better than the average. Again, nothing to brag about though. We're only at 40%. The average was a third. So it says, again, if you missed a question, this is probably it. It says, an 800 Newton person is standing on a bathroom scale in an elevator car that is moving upward. As the car slows to a stop, which describes the reading of the scale? We talked about how if you're in an elevator, you have a couple of forces acting on you. You have Fg, and then you have a normal force going upward. But that normal force will change depending on what your net force is in the scenario. So we really need to figure out what the net force is in this scenario. So it says that this elevator is moving upward. So the velocity is up. I don't really care that much about velocity. I care more about acceleration. Okay, because acceleration is what tells me what my free body diagram looks like. Remember, we can't tell velocity from a free body diagram, so you also can't use it to make one. Okay, but I can figure out my acceleration because it says that it's moving upward and slowing down. And those two things together help me. Because I know that if I see something is slowing down, it means that my velocity and my acceleration are in opposite directions. So this is a positive velocity. The fact that it says I'm slowing down means that my acceleration has to be opposite. My acceleration has to be negative. Okay, so my acceleration is going this way. That's the only reason it would slow down, is if they're in opposite directions. So you do actually need both of these pieces of information so you can get this. Okay, so my acceleration is this way, and guess what? If my acceleration is down, then so is my net force. And if my net force is down, then when I draw this diagram, I need this vector to be larger than that one. That's the only way you get a net force that is down. So when I draw Fn, I need to draw it shorter than Fg because I have a F net that is down. Okay, so down needs to be bigger than up. Is everybody okay with that? Okay, and so if I answer this question, it doesn't even actually ask me to do the math. We just have to answer it conceptually. We talked about how a bathroom scale or a scale is going to read your normal force. And so here's my normal force. My normal force is smaller than my actual weight. And so the scale would show that he weighs less than he actually does, which means that the scale would show that he is less than 800 newtons. The answer to number 14 should be C. Guys, these elevator problems, once you get the hang of them, they're really not that bad, but I am aware that they're a little bit tricky. Okay, you might want to look back at it. I'll talk more about that in a second. But before I do, does anybody have questions about this one? No? Okay, then let's look at the last question, and then we'll come back to a couple things that I want to mention before we leave here today. All right, this is number 15 for Form A. It says, which of the following correctly labels the forces in the diagram below? So you have a free body diagram with some labels A, B, C, and D on those vectors, as well as a note that says this box is moving to the right, which is a super helpful piece of information because one of the forces I have to label is friction. And friction is always opposite the direction of motion. So if this box is moving to the right, friction has to be to the left. And the vector pointing left is this one, which means friction has to be C. If I look at my options, that means right off the bat, I can eliminate A because it says friction is A and it's not. I can eliminate D. So I've already reduced my choices, so I have a 50-50 shot. Okay, you may have thought, well, let me start with force of gravity. I know which one that is, but you'll notice that one we gave you the same answer for all of them. Okay, so you have to look at some of the other ones. Friction was a good one to start with. But we can either look at normal force or applied force next. I'm going to go ahead and look at normal force because it's right next to this one. I'm just going to read it this way. Again, your normal force is the support force from the surface, perpendicular to the surface, in this case, whatever surface this is. I don't know if it's a floor or a table, but there's my surface. The perpendicular force to this surface, the support force, is this one. So my normal force needs to be force D, which is that right there, which means the answer is answer choice C. That means that friction is here, normal force is here, gravitational force is here, and this is my applied force. Okay, questions about number 15? Okay. All right, so tomorrow when you take your test, obviously the multiple choice questions you get will be pretty similar to the ones you've already seen. I think that's been the case on most of our tests thus far. The quiz is usually a pretty good preview. That's going to be true for this one as well. But remember, your test also has free response questions. And that, of course, makes it a little bit different than your quiz. It will be given in the same way that it was last time, where you will have your multiple choice section. You'll have half an hour. Well, actually, change that in a second. But you're going to have the multiple choice section for you guys before lunch, and then when you get back, you'll have the free response section. And the other classes, they just get a timer in the period. But they also get the same amount of time that you guys do. And it's broken up the same way yours is, even though they don't have lunch. This time, we're going to give you one of the pieces of feedback some people gave on the last test was they wanted more time on the free response. So we're going to add 5 minutes to that and take 5 away from the multiple choice. So it'll shift it a little bit. So your multiple choice, you'll have 25 minutes and you'll have 20 minutes for the free response. So just as a heads up, because that's what we talked about today in our physics meeting. So that's what we're going to do tomorrow. So that should hopefully help some of you out, although that does mean you can move a little bit quicker on the multiple choice than you were before, but that didn't seem to be a problem for you guys last time, nor did it seem to be an issue for most of you on the quiz, so it should be pretty similar. However, this one, the free response is going to look a little bit different. We did something slightly different. You're only going to have to answer 2 questions, okay, instead of 3. But whenever you get the free response tomorrow, there's going to be 2 sides to the page you get, a front and a back. Okay, both sides have 2 questions on them. And the reason that we printed it 2 sides is because you're going to get a choice. And I'm going to tell you at least an idea of what to look for, because tomorrow I don't want you spending 5 minutes trying to figure out which side to do. Okay, so one of the questions is the same on both sides. Okay, so you have to answer that question regardless. But the first question, there's 2 versions, one on the front, one on the back. Okay, and you get to pick. So you are either, if you want, and this is why I said I was going to come back to it, if you want to focus on elevator problems, you will have one, okay, as one of the options. If you're like, nah, then don't. But I'm telling you right now, if you want to study elevator problems, you will have that as one of the choices, and you are welcome to review as much as you want prior to coming into taking it. So that's one of the choices, will be a calculation for an elevator problem. You have a couple of them in the notes you can look back at. The other option is going to be just more of a standard, there's a force pushing or pulling, I don't remember, something across a surface with friction. And you have to do calculations for that. So it'll look more like what we did on this problem. Okay, except we didn't, those pictures were already there, but you'd have to, be able to figure out all those pieces. Again, we did some of those in the notes as well. So you've got a couple of different options depending on which one you feel more comfortable with. If you, again, you can I'd study both types, obviously. But if you start looking at one, you're like, nah, I don't know how to do this. Don't waste any time trying to figure it out. If you look at it and you don't know, flip it over. Okay, because that's the thing that we want to make sure you're not doing, is spending 7 minutes reading the question and trying to figure it out before you change your mind and go to the other one, because we don't want you to lose that time. So keep that in mind, and that is an idea of what you can look at for those 2, because you'll have a choice between them. So you can flip it over, read them both real quick, and then say, this one seems easier, I'm going to go this route. Or if you start it and you get to a point you're like, I don't know what to do, again, don't waste the time, just go to the other one if you're not sure. Okay, so anyway, that is a little bit different, but we figured we would give you the choice. And so you can focus on studying for whichever one you think you feel more comfortable with, or whatever you need to do. But look back at the notes and the examples. Again, you guys have a unit summary with additional practice. Use it. Okay, there are questions in the unit summary like the stuff that's going to be on the free response. You have your problem sets that you've already turned in, at least hopefully already turned in. Use those. Again, there's example problems in there as well. So if you are looking for additional study time, whatever, you are more than welcome to come after school during tutorials today. They'll be with Miss Begg or with Mr. Guthrie, and you can even just work on your unit summary in there. And that way, if you get to a question and you're like, I don't know how to do this one, you can just raise your hand and ask them, and they can come over and work it out with you, or work it out on the board for everybody who's in the room. So again, you have some opportunities to, some resources to look at, some opportunities to get some additional help. But if you guys have questions for me, let me know. Otherwise, you have a test tomorrow. Please make sure that you are studying for that.